Here we are for question number 5. And look at these two beautiful Chihuahua dogs here. They're similar to each other. The smaller one is 12 inches tall, and the larger mutant one is 54 inches tall. He's been eating some pretty fierce tacos here. All right. How many times the height of the smaller Chihuahua is the height of the large one? Okay. Very simple. 54 divided by 12. That's 9 over 2 as a fraction. 4.5 as the ratio. This is the most important ratio because we're going to use this now. This is for their linear length here, so we got inches tall. Now we're going to use that for finding the area and the volume ratios. So we have to hang on to that. All right, so how many times the surface area of the smaller Chihuahua will the surface area of the large one be? Okay, so remember what that is. That is our ratio between the lengths squared. 20.25. Or if you kept to the fraction, which has some advantages also, because when you do proportions later on in this problem, it's real easy. It's all set up for you. You don't have to do any guesswork about whether to multiply or divide to solve it. So it's 20.25 or 81/4 for our ratio for the areas. All right, then how about how many times the volume of the smaller Chihuahua will the volume of the larger one be? Okay, again, we're using our ratio here, 4.5, this time cubing it. Or if we kept the fraction, then we get 729 over 8. 9 halves cubed equals 729 over 8. So you either have the decimal version or the fraction version. Equivalent amounts. 729 divided by 8 would be 91.125. So here's the first half of it now. We've set up our ratios that we need. This is for length, and this is for area, and this is for volume. Okay. We'll use these ratios in the next 3 questions here. All right, the smaller Chihuahua has a surface area of 100 square inches, weighs 12 pounds, and one of its legs is 6 inches long. All right, so what is the larger Chihuahua's surface area? All right, what's our ratio for area? It's 20.25. So we have 100 times 20.25 because smaller Chihuahua is 100 square inches. So now, since they're similar, we use the area ratio here, which is 20.25. And you see we get 2,025 inches squared. If you use the fraction version of that, that was 81/4. And we have the smaller one here. So then you get the smaller Chihuahua on the bottom. Okay, and you can cross multiply and solve that. 2,025 inches squared. You'll get that either way. All right. What is the larger Chihuahua's weight? All right. Well, it weighs 12 pounds. Weight is related to volume. So we use the volume ratio, which, remember from the previous slide, was 91.125. So that equals 1,093.5 pounds. So don't mess with this big mutant Chihuahua. You'll be sorry if you did. Because that's one big dog. All right? What about the larger Chihuahua's leg length? Now we're talking about straight length here. Let's get ourselves a different color. Alright, so we got 6 inches, and our length ratio is just 4.5, or 9 over 2. So multiplying that out, we get 27. So this dog will give you a run for your money, so watch out. 27 inches, so this is how we relate. We find the most important ratio we found was this one right here, the 4.5, because everything was based off of that. So our very first ratio we found on their lengths, that was their heights, so it's just linear length, and then we got our area and our volume ratios off of that. So here is the Chihuahua mutant problem solved. See you on the last one.